Hi, can everyone hear me?
I can hear you.
Hey, Maureen!
Hi.
How are you doing?
I'm great. How are you?
I'm good. I'm gonna pause the recording for now. We would invite all of our attendees today. This is our December Winter 2019 Software Preservation Community Forum. We invite all of our attendees today, if you have a topic that you're interested in discussing and or having special guests to come and discuss, please submit your questions in the form that's linked in the meeting notes. And please think about volunteering to give a lightning talk about your own work on a future forum. And with that, I'd like to briefly introduce all of our guests today, and then I'll be muting. We have Maureen Grumpeter from the Software Heritage Project. She'll be talking about the University of Pisa and Software Heritage's collaboration on the software heritage acquisition process. We have Zachary Firsty from Carnegie Mellon University, who will be talking about the use of legacy software and emulation in the classroom in the School of Architecture at Carnegie Mellon. And we have Henry Lowood here with us today from Stanford University, who will be discussing and introducing the Silicon Valley Archives and Stanford's participation as a partner on the GitHub Arctic Archive project. And with that, I'm going to hand it over to Maureen.
Thank you, Jessica, for this lovely introduction, and thank you for inviting me to speak again on this community call. I'm going to share my screen for everybody to see, and I will start the presentation. For the ones of you that don't know, Software Heritage, the Universal Source Code archive all source code publicly available at the moment. I am their metadata specialist, but I also have another hat on the Software Heritage team. I work on the collaboration with CrossMiner, which is a developer-centric knowledge mining project for open source software. Also working on metadata there. It's very interesting, but as I said to Jessica before, here now, my background is computer science. I'm a software engineer, and I started the metadata only during the Software Heritage Project, but it's very interesting, and for preservation, it's crucial. But let's talk about software heritage and the acquisition process. So to introduce a little bit for the ones that don't know software heritage, our goal is to collect, preserve, and share all the source code of all the software by being a reference catalog to find and reference all source code from different origins, repositories, package managers, and anywhere actually. We want to become we are the Universal Archive, which preserves all the source code and a research infrastructure to enable analysis of all the source code. To continue and explain why this is so important, I'm going to discuss a little bit the Paris Call, which was signed in November 2018 at the UNESCO headquarters by experts. Some of, maybe, I don't know if they are on the call, but some participated from the Software Preservation Network to recognize software source code as a precious asset of humankind, to support the development of shared infrastructures, and to foster international collaboration to build a common framework. The Paris Call includes many points that says really that software source code is very important. On this presentation, I won't explain how software heritage is archiving software source code, but you can find all this information on our website. Here when I publish the slides, you can go and see the full text. I can also put it in the notes later after the presentation. Recently, we joined the GitHub Arctic program, and this is a very, very impressive to see that GitHub has joined forces to preserve the humankind's source code or at least has joined the strategy to do so. It's a testament to the importance of software source code preservation. It's a multi-partner strategy for archiving code, and there's a range of storage solution from real-time to long-term storage, but all you will learn about it, maybe more with Henry's presentation. So I'm leaving that just to say how important it is to preserve the source code. And now to the real reason that we are here, the acquisition process. It's a turning point. Looking at the past, we see that software is vanishing, and we need to collect it now and put it in a safe place. The people that are behind the software are still here, and it's urgent to collect their knowledge. We have only a few years left, and we are looking at the future, and we want to provide this universal archive for all source code, and this is the time. With the Pisa University, we started a process that's called the acquisition process, to gather and preserve artifacts that might be digital and might be not digital, that encapsulate the knowledge in the software. So this is the software heritage acquisition process. It's also a very nice document that you can read. The goal of the document is how to rescue legacy software from different media, physical or digital, legacy, which is unsupported media or recent media, and how to create the code by reconstructing the development history and collecting the metadata. I was discussing the acquisition process with Jessica, and we really want to collaborate on this subject to see if this acquisition process is missing something, or if you should, well, I would like you to join and see how it's constructed and see how we can improve it together. So the last part of the acquisition process is eventually illustrating the preserved artifacts in a way on the web or physically in a museum. So this is the 4 phases of the workflow that we need during the acquisition process. The first phase is collect. There's a collector that will gather the physical material and the digital material in a warehouse and in a depository. The depository is a digital place. Now, for the Pisa project, for the University of Pisa, we use GitHub as a depository. During this phase of collecting, nothing would be changed to the artifacts that collected, but there will be a journal capturing all the entries to this warehouse and depository. The second phase is the curate phase, transforming the things that we gather that are legacy into a curated source code deposit that can be accessed and reviewed by everybody. So this is the curate phase. Also, we can see on the last line that some of the information should be captured in the wikis. So information that we gather on paper or in other places that need to be preserved can be preserved in a wiki. Afterwards, there's the archive phase, passing from the curated software deposit to an archive. Here, we archive it in software heritage. And the last phase is the presentation, where to present, who is the person that can work on the presentation of these legacy artifacts. One of the examples that we found in the Pisa with the Pisa University was the Theomuse code. It was the control code for the music synthesizer Tau 2. As you see on the screen, it was this piece of paper. It was transcribed into a GitHub repository. It was written in Fortran, maybe, as you say it in English. In French, it's Fortran. And developed by a group led by Master Pietro Grossi. And one of the videos you can find on YouTube that shows the music is Le Sacre du Printemps, which is very interesting to view and to see that this code, not this specifically, but code that was written for the Tau 2 synthesizer is gathered with other artifacts, music artifacts, video artifacts, images, and everything together is linked. This is the goal we want to achieve with this acquisition process. So a bit of technicality, how we did all of that. First, on the GitHub repository, we the Pisa team, the University of Pisa team, has constructed a repository for each project, for each piece of code, with two branches. Here we have the master branch, where we captured metadata and new information, and you can see on the screen a code meta file which captures the metadata. On another branch, you have the source code, which is the unchanged source code committed in 2009, but written in 1972, as you can see on the screen. And the next stage would be to add this GitHub URL to the Save Code Now in the Software Heritage Archive. University of Pisa constructed automatic process to do so, to have a Save Code Now go and save all the projects they found. And on the archive, you can then browse the source code. Here is the subroutine Calmus file that you see on the screen, which is the same that was presented before on paper, which you can now reference with our software heritage IDs available on the permalink box. Something new to share with you is that we have the new badges. So this is the first time I present, so I don't know how really to present that, but you can now go to our website for your repository and get a badge and put it on your README or reference it on your web page, and you'll have a very nice link to software heritage, to your software heritage archive repository or specific artifact. So this is the acquisition process. I don't know if I have, maybe it's enough time, but no, I'm open for questions. Here is the links to the Save Code Now, to the Software Heritage Acquisition Process Guide, and on the, this is a GitHub repository on which you can open issues and contribute to the guide. It's not fixed in stone, it's a process, and we should continue the conversation about that. And we have also a mailing list dedicated for the acquisition process, which is really focusing legacy software. Thank you.
Maureen, that was wonderful. Thank you so much. I would invite our attendees to post any questions to the chat. And while we wait for that to happen for a few moments to see what questions people have, I'll ask a question. Maureen, you touched on this during your presentation, but you mentioned that the resulting acquisition process was largely really based on the University of Pisa kind of example, right? A specific institutional kind of context in which y'all were working through this acquisition process. I wonder if you could talk a little bit about that, but then leading from that, one, if other institutions want to take the acquisition process and think about it in the context of their existing digital curation workflows, how would they get feedback? I know you have the mailing list posted, but what might be other ways to get feedback about the acquisition process to you or other members of the team?
So I will start with the first question because you have two questions there. So the first one is about Pisa, the University of Pisa. They came to us because they had a very important historical event in October that they wanted to present for this event, legacy artifacts, machines, and source code. And together we developed the acquisition process, but the acquisition process in itself is something universal, which is implemented in a certain way for the University of Pisa. So if you go to GitHub on UniPisa/something, all of the UniPisa projects are, or maybe not all, but some of them are for the acquisition, were developed for the acquisition process, and you can see there that. And for your second question, you can get in contact with me, and it's better to do it on the mailing list, or that depends on the institution and what your needs are. But if you want to have something like a community discussion on one of the aspects of the software acquisition process, it should be on the mailing list. But if you want help in implementing the acquisition process, you might not want it on the mailing list, and you can go directly to me. But maybe it depends on the person. I think that the mailing list is a very good way to start going back and forth.
That's great, Maureen. Thank you for answering that question. And before we move to Zach, I just want to call out Cal's question here. How do you deal with changes to the software over time, especially for actively updated code? So maybe it's worth making the distinction. I think I remember from our conversation that this process would be for things that have already been designated as no longer active projects. Is that correct?
Exactly. You can imagine how you want to preserve artifacts of things that are now active, but I don't think that goes under the category of legacy software. We should discuss this more, but if you're not looking at legacy software, we at RS Software Heritage, we do fetch the repository periodically. So we do have the evolution and the history, development history. So even if a legacy software was developed during 10 years, it will have, we will try to construct its development history throughout the 10 years, and not only just one artifact for this project. This is what's interesting about software. It evolves over time and should be captured with the development history.
Lovely. Thank you so much, Maureen. I know other attendees on the call may have questions. It looks like David has a question. David, we want to make sure that Zach and Henry have time. So we're going to grab your question from the chat and put it in the meeting notes, and maybe we'll have time to circle back. So with that, thank you so much again, Maureen. Again, there might be more questions at the end. We'll see. If not, we'll gather them up and provide some other means by which you can answer them publicly. So I'd like to switch the mic.
Hello, everybody. Can you hear me? I think Jessica cut out. Do you hear me?
Yes, we can hear you.
Okay, great. Yeah, my name is Zachary Firsty. I am the CLEAR postdoctoral fellow in software curation at Carnegie Mellon University. And my background is that I'm a historian and theorist of media, especially media used in the arts. And I'm talking today with you all about a pretty exciting instance of using a software preservation network project, EASY, in the classroom. And we think it's the first time this has been used. So I'm gonna kind of go through, let's see, give you a little roadmap here of what's coming up. So I'm gonna go through the background a little bit of the course, the logistics of emulation as a service for the classroom, give a survey, look at a couple of the student projects, and talk about some of the questions raised by the course and the collaboration, and hopefully have some time to field questions from everybody about this stuff. So for the background of the course, the title is Special Topics in Computational Design, Experimental Archaeology of CAD, CAD being Computer Assisted Design, or computer-aided design, and it's taught here at Carnegie Mellon by a professor named Danielle Cardoso-Locke. And the emulation process is co-coordinated with someone many of you probably know, Eric Kaltman, who's now professor at CSU Channel Islands, used to be here at Carnegie Mellon. And it was a small course consisting of an undergrad and master's student and 2 PhD students, which that format turned out to be very useful for us in this kind of testing and troubleshooting phase. It was offered in the College of Fine Arts here at CMU, and within that, the School of Architecture, and within that, a program called Computational Design. So it was given in a context, this is a mixture of kind of the history and theory of using computation to design, as well as the creative practice of this. A little bit more on the course, here's a quote from the syllabus saying that computer-aided design systems are artifacts of cultural and technical significance, which shape the intellectual labor and professional identities of many architects, engineers, and other designers. This project-based course explores them as territories of both historical and creative inquiry. So it treats CAD software, in other words, as primary sources for historical research, as well as inspiration for creative practice. And I think this is something that I found very gratifying and exciting because a lot of the discussions that we have in the emulation world and with EASY are about the wonderful utility of the platform EASY, which many of you are familiar with, but in case you're not, it is a software preservation network project that puts emulation into a browser, basically, so that rather than installing virtual machines locally, you can just type in a URL and boot up, say, Windows 98 or an old version of Linux or something right in the browser. So as I was saying, one of the interesting things, we've been very excited about the utility for this in, say, rendering an old file. The common example is of old census data in an obsolete format that can't be opened unless you have Microsoft Access 97 with all the right updates. But something that I found exciting about this class was that even beyond getting access to that old data that might be kind of hidden away in obsolete formats, was kind of the real promise and fertile ground of looking at the software themselves as bits of historical artifacts. And that's exactly what the course was about. And the readings and the discussions for the course really emphasizes a distinction between tacit and explicit knowledge. Explicit being, articulated explicitly knowledge, and tacit knowledge being something kind of learned inarticulable in some way. And that's something that I think really played to the strengths of the EASY system and emulation more generally. So the course was structured around these 3 parts here. First, each student did a reconstruction of a historical system, and I was able to watch all the presentations for this, and just earlier this week was at the exhibition for kind of the final presentations of these 3 steps in the class that each of the students gave. And it was really fascinating to hear the range of these historical systems. None of them were they were all reconstructed in the sense that they just had documentation, maybe kind of like what Moran was talking about with the old Fortran code that was just printed out, and they would kind of reconstruct and try and make a functional operating or a piece of software based on, in one example, it was an MIT thesis from the 60s trying to plot out usable land in an area and kind of making a grid and saying, okay, there's a river on this, there's this level of incline or decline on this, it's this close to an urban area. And so the basic logic was contained within that thesis, and the students reconstructed using contemporary programming languages, the logic of that. And then the second step where we came in, where Eric Kaltman and I worked with Professor Cardozo and the students, was emulating legacy software. And so I'll give you examples in a little bit about what the students did, all looking at a range of design and kind of visual tools, historical tools. And then lastly, the third project was the development of the students' own speculative system, which speculative in the sense of kind of experimental, perhaps they're going out a bit on a limb. And the idea was that after reconstructing and after emulating, they had material for kind of thinking of something new, something creative, kind of outside of the box of normally what's within the range of possibilities for a design system, for computational design. So I just wanted to put this up here. I think hopefully I'm not horrifying the metadata specialists here too much with a kind of haphazard way that these are laid out, very much for the specific purpose of the class, to make these legible to the students in the class so they knew what each of these instances are. And so, yeah, as I was loading these all in for kind of the deadline of the class, I broke some of our formatting procedures, which gets to an issue with using EASY in a kind of public-facing way that I'll talk about in a little bit. But here, as I said, EASY is a system for spinning up different virtual machines and environments within a browser. So I just wanted to give an example of some of the options. And there are some others that you can't see in the screenshot under the virtual machines tab here. But students basically were able to romp around in here, do a little fiddling, and then pick one of these. Each student picked one of the legacy software systems to look at in depth. So I want to talk now a little bit about the logistics of emulation as a service. And first, thinking about the logistics from my perspective as the person loading the target software into the EASY platform. So first of all, using it in the classroom was a really excellent chance to test kind of ingestion workflows because we had a specific timeline, a specific end use, and specific bits of software. And so there were a lot of things that I discovered about exactly how the EASY system works, of stacking differences. And so, for example, when I had to load a program that, say, there was this old program called ArchiCAD, and it had its in one case, it had a serial on a separate disk. So there was the license disk. And in order to install the program, you had to copy the license from the disk onto the hard drive, and then you could use that later during the installation process. That was something that we hadn't really accounted for. I mean, there are different parts of the EASY documentation and the UI that deal with licenses, but the idea that that would end up becoming its own environment, so that license was then accessible to the installation procedure once I loaded that thing in as the virtual disk. Stuff like that popped up, and so it was very helpful to kind of solidify and clarify some of the workflows. And similarly, it was a really excellent crash course in bootstrapping environments. So one of the environments that I didn't show was an old Macintosh 7.6 environment that was loaded with a variety of software that had been laying around the School of Architecture for the last 20 years. And it I was a little disappointed that none of the students went that way and did any of the projects, because it was a lot of work to figure out exactly how to start that environment, given that it uses a different kind of emulator rather than the QEMU, which is a very common emulator that all of the Windows 98 and Windows XP environments were using. These old Mac environments has specific requirements about a ROM file, and so it was a really good learning experience for how to use different emulators and how to import those, and to kind of test each of the things in the documentation that were only kind of an eventuality before this project. As I said, it's also really gratifying to have a specific use case in mind while doing this work, and to know, I mean, in my case, I got to know personally the students that would be using this, and had kind of that immediate feedback. So that was a really, I think, special case in kind of the archival world where we have that feedback. Now, from the perspective of the users of EASY, this was something that I asked a lot of questions for. I think, first of all, it was very, before I get to that point, actually, it was an overwhelmingly positive experience. Students were very excited and impressed with the idea that they didn't need to install anything locally, that they could just go on a browser. They didn't even need to use the same machine, you know, to pick up their work. So there was a lot of excitement in this capacity. But I wanted to bring up a couple of the feedback issues that I got from the students that have prompted further thought. First of all, so the UI menus for, you know, environments, virtual machines, and objects, which is the way that EASY lays out these different holdings, is not necessarily geared, I would say, toward the end user, and very much, you know, that screen that I showed you a clip of, that's the admin screen. And so at this stage in the EASY project, there's not kind of that service level UI, which did cause a little bit of confusion, not too bad. And that's why, as I said, I kind of tried to lay it out as cleanly as possible, even breaking some best practices and metadata that I'll have to go back and correct. And there were a couple technical issues, such as students were talking about mouse acceleration and mouse lag when they're in these different environments, but that has been drastically improved in the last update. And another one was a lack of simple output from these different environments. So it's really easy to just connect from anywhere and be able to load your AutoCAD 2000 in Windows 98. But it was more difficult, and we didn't have the ability to output anything that they produced, which, especially from a creative perspective, but also from a historical research perspective, I think is really important. And I think that's something that we've been talking about among the EASY group, and something that will be coming out. And lastly, there was authentication procedures. So because we didn't have a lot of very sensitive things within that admin screen that I showed you, we ended up just passing around the password for that. There was not too much they couldn't muck with kind of the underlying server or installation like that. Worst comes to worst, they accidentally deleted an environment or something like that. But because we were just passing around the password, you know, of course, that's not best practices security-wise. So I think that's something that it raised. So the next point is I wanted to point your attention to 2 publicly available student emulation projects. I also put these links into the agenda so you can take a look, and now I'll just show you just some visuals from what the students did. This is one student who was working, this is a time lapse, of course, but was working with AutoCAD R12 for MS-DOS, which came out, I think, in 1986. And one of the things that this really emphasized for me is because as I was setting these up, I'm not an architect, I'm not a designer. And so I could set it up and think, okay, this looks like it works, but it really took some of those specialists getting their hands on the keyboard and saying, oh yeah, sure, they know what to do here. It is functional. And so I found it very interesting to watch. And kind of the feedback that the student, Jin Mo, the student that made this project, said was, really, there's not that much different. A lot of the AutoCAD skills that he learned on Windows XP and later versions of Windows directly translated over to the MS-DOS. And he was able, you know, after adjusting a couple of muscle memory things, able to jump right in to designing. So I'll show you another one that's that was a kind of command-based. There's this Vista Pro program in this instance for Windows XP, and it was from the late 90s to the early 2000s, and it's kind of this landscape generator. And one of the publicly available projects that I provided a link to was thinking about this landscape generator and its role in kind of forming a visual imaginary, and makes this very interesting comparison to GANs and algorithmically generated, neural net generated imagery that's becoming very popular in contemporary aesthetics. Another student was working with Maya 2010, which to her, this undergrad was a legacy old software, and she really didn't know what to do with it, but it was interesting to read. This is another one with Public Medium Post, and you can read Jules talk about the process of kind of getting to know these things and her observations about using this. And one thing I wanted to note is that all of the work and the research that the students produced was really interested in layouts of things like these tabs here. If you can see my cursor, the black one here, and all of the menus and the way that that kind of influenced design choices. And I think all of those things would be kind of impossible or incredibly tedious to document in a way outside of emulation. So I think that's a really unique opportunity that emulation provides, is to allow a researcher to interact with every nook and cranny of a piece of software in the way that it was originally designed. So very quickly, I'll raise a couple of questions. First of all, it was how to structure the user-friendly metadata for computing environments, as I talked about, just to make it so that a student or an end user can easily see, okay, this is what's coming. And I think in the future iteration, the new 1.0 release that's coming out next year of EASY, that's a huge goal, and we should make a lot of progress there. Similarly, coming up on the next iteration is permissions and access for platforms like EASY. And something that I mentioned earlier that I wanted to emphasize is the range of use cases for software preservation that this provides. Rather than just rendering historical files, legacy software is an interactive environment, and that can be uniquely important for research and creative practice. And the last few questions were just about kind of logistics of how might you bundle an environment like this into course material? How would you incorporate it into interfaces like Canvas or Blackboard? How would you, share a hyperlink to something like that? And also how to frame the legal status of preserved legacy software in the context of pedagogy and student use. Because we at the SPN know that we have an exemption to DMCA rules about cracking legacy software if we have rightful ownership of it. But I think explaining that, how that translates to individual students, how fair use covers what it does, is something that it raised in my mind that I would have liked to be able to give a more definite answer to. And lastly, it really raised the need for collaboration with specialists when ingesting and testing the software. Like I said, I got that screen of MS-DOS AutoCAD, and it looked like I didn't see any errors, but it took an architect to be able to say, yep, this is fully working. Great, and that's anything. I look forward to any questions that you all might have.
Zach, thank you so much for your presentation. One, as Jess mentioned in the chat, just personally, I would love to take this course.
Right, yeah, it was really fantastic.
Yeah, but all the questions you raised at the end, wow. It looks like we have a question already. Yeah, people would love to have the time-lapse video. I think that's a very effective way of just how people are working in the space. So that's that comment. It looks like Moraine has a couple of questions. Yeah, here's one. Compile and run source code, or was the software only from executables in terms of the environments you created for the class?
This was all commercial software from executables. So it was entirely CD-ROMs and in a couple of cases, floppy disks. Yeah, it was a really fantastic course. I wish I could take it too, but I was so happy to be involved and kept showing up to class even when I wasn't explicitly invited. It was a great way to start my week on Mondays.
Yes, this is, I think also maybe taking everyone's, for Moraine and for Zach, having a link to your slides, if at all possible. I think that that would be helpful for people. I know we may not have captured all of the links and certainly not all of the questions articulated in each of your individual presentations in the meeting notes. We just have a couple of links for each of you. So I think sharing your presentation, if you're willing, would be great. And then Zach, I think that another thing would be to Moraine's question about source code, compiling source code in the environment as opposed to using executables. One thing that I'll just flag here is that something Moraine and myself with my easy hat on have been discussing is the when and how we might be able to do a pilot to be in an easy environment and work with the OpenSLX team to see how difficult it would be for users to be able to send a call to the Software Heritage API to pull source code into the environment and have it compiled within the emulated environment. So I think that the case for doing a pilot to see just proof of concept is pretty strong here. Yeah, and Doug, okay, would love to see this done with scientific equipment software like chemical modeling. Yeah, definitely. We've had some use cases come up for microscope software, software that runs, yeah, other kinds of lab equipment. And Stephen, yeah, links to the presentations today. We will do that, absolutely. And then if you have any other questions for Zach, or Moraine or Henry, which hasn't had a chance to give the presentation yet, please do keep in mind if you put them into the chat or into the meeting notes document, we can capture them and we can circle back and we can flesh them out and have more detailed discussions about some of these topics in future forums, even if we don't get to your question today. And with that, I would love to thank Zach so much for an incredible and also inspiring presentation, just to hear about the students' experience of using this legacy software and sort of the discovery process for them around this. So thank you, Zach.
Thank you.
And with that, let's pass the mic over to Henry to talk about both the Silicon Valley Archives as well as Stanford's participation in the GitHub Arctic Archive project.
Yeah, thank you. Good morning, everybody. It's still morning here in California. Okay, I'm going to talk less about tools and specific workflows and things like that than I'm going to talk about programs and projects at Stanford, and specifically the work of the Silicon Valley Archives, which I lead as the curator. The first thing I want to talk about is basically good news that we got now a little over a year ago. We received a gift from the Harold C. Hobach Family Foundation for $25 million, which we'll be receiving over 5 years. That gift is going to make possible the opening of a new center for the Silicon Valley Archives, probably opening in the fall of 2021. It will also involve the reconstruction of the east wing of the main library on campus to accommodate the Silicon Valley Archives, which will include, office space, visitor space for researchers, special collections teaching room, an event space for, lectures of up to maybe 80 people to 100 people, and an exhibition space, which we have not had previously. For those of you who don't know, Silicon Valley Archives has been around for a while, since the mid-1980s. We're focused on the history of science and technology in this region in Northern California, specifically technology-based entrepreneurship and how that's sort of panned out over the 50, 60 years, however you want to measure it, of that kind of activity in this area. The program began as the Stanford and the Silicon Valley Project in the mid-1980s around archives that were already at Stanford, about Stanford projects. We kind of moved out from Stanford into the Valley, collecting papers of individuals, engineers, entrepreneurs, and so forth, but also of companies like Apple, Intel, Varian, some of the major companies of the Valley have given us extensive documentation that we have here. So it's become probably the largest set of collections on high technology industries, as they used to be called, anywhere in the world. We focus on physical archives, but also on digital archives, including software. Some of you may have heard or come across the Cabrinety collection, for example, which was the first significant software collection to be acquired by a cultural repository. We acquired it in 1999. What I want to talk about today, just to kind of give you an overview, is just a couple of the launch ramp projects that we'll be starting in the next couple of years, 3 in particular. And then the third will be the GitHub Archive project, which I'll finish up with. So what's happening is we're gearing up to fall 2021. We have a year and a half. Unfortunately for my workload, we already announced that we're expanding, so we have to do something, right, before we actually open up this new center. And what we've done is we've decided to start up 2 new projects for us. The first project is called Medicine and Innovation. It's a series of oral histories and an archive on the history of medical technology. Medical technology, not biotechnology, medical technology, devices, stents, artificial hearts, catheters, things like that. That's not an area Silicon Valley is well known for, but in fact, is a very significant area. It also happens coincidentally after the project launched, we realized that Harold Hobach, whose foundation funded this gift, whose name I now carry on my curatorship, which is endowed, one of his largest areas of activity as an IP lawyer, that was his area, he was part of a very significant law firm here in the Valley, was medical technology. So there was an interesting link back to the donor in this project. We've already started some of these oral histories. We've done 3 so far, and we've laid out a project over the next year that will probably get us to about 15 or 20 interviews. This follows on another project called Silicon Genesis. Some of you may have run across, which we've been running for about 25 years now. These are oral histories in the history of the semiconductor industry, something that is more familiar as a piece of Silicon Valley. Okay, so oral history and archives represented there in that new project. Another thing is that, we've done a really good job, whether it's paper archives or historical software, in dealing with history through the early 1990s, let's say, 70s, 60s, 70s, 80s, 90s, all of that. We've done less well in capturing the ways that the Valley has changed over the last 25 years, new technologies, new areas of activity, and also the way the makeup of Silicon Valley has changed and the participants have changed. So the second project we've launched is called Histories of African Americans in Silicon Valley. We're working with a documentary filmmaker, Kathy Cotton, who's done a film about African Americans in the Valley beginning in the 1950s. I've learned from this project, for example, that Hewlett-Packard was a very progressive company already in the 1950s with regard to minority hiring and that sort of thing. And there were a lot of very significant contributors from the African American community at HP. Anyway, we've started that project up. We've had a couple of meetings with some of the pioneers from that community already. And there we will be dealing with projects around creating documentation to where archives have really not paid much attention before. So there really is no tradition of collecting within the African American community in the Valley. We're going to have to, figure out what kinds of documentation are available, talk to people, use interviews as a way of maybe filling in where the archival documentation is not available. And by the way, one of the areas, I mentioned HP earlier, one of the areas where African Americans were particularly active at HP in the 50s and 60s was in HP's computer division. The first HP computer was designed by a team led by an African American engineer and so forth. So there is a history of computing aspect to this project as well. The last thing, and again, my remarks are going to be fairly brief so that we have a little time left for a couple questions. The last thing I'll talk about is the GitHub Arctic Archive project, which is a project partly of the Silicon Valley Archive at Stanford, but also of just about every other department and group you can imagine, such as Digital Library Systems and Services, which is basically our IT group in the library. And they're also very much involved, or will be very much involved in this project. So the GitHub Arctic Archive is a collaboration of multiple institutions. It's really pretty impressive when you see the lineup here. It's Internet Archive, Software Heritage, as we've already seen, the Long Now Foundation, Stanford Libraries, Microsoft Research, that would be the Silica Glass project, GitHub itself, the Arctic World Archive, which is itself a collaboration of a company called Pickle and the Stora Norske Spitsbergen Coal Company, which is basically the coal mine, mines that way up in the north in the Arctic that have been made available for preservation purposes. Pickle has been responsible for the technology for doing that within those spaces. Okay, so what is this project? Obviously, we're archiving GitHub, which is big in itself. By archiving GitHub, we're taking a big swing at the problem of open source software and documenting that. Now, the details have not been ironed out entirely for this project. It was only recently announced. It was announced in November at GitHub Universe. And yet, the announced date, I noticed by checking this last night, the announced date for the launch of the Arctic Vault is 02/02/2020. So February 2nd next year. That's so coming up pretty soon. Here's my understanding of what the major components of the project are likely to be. The first component, the main one that's suggested by the title, is deep storage of the GitHub open source software repositories. Possibly, it wasn't clear to me, but possibly at some point on Microsoft Silica Glass as a storage medium, certainly not in next February. It's not there yet as far as I know. But the storage of the repositories in the Arctic World Archive. So some kind of snapshot apparently will be taken in February and then will be deposited there in these former coal mines in the far north of Norway. Okay, so that's a definite baseline goal of this project. Secondly, there will be archives hosted by the Internet Archive and/or Software Heritage. Software Heritage actually, as I understand it, already has pretty much the GitHub archive there. So this will be for ongoing project access, that kind of thing. And then thirdly, a curated sample of collections. This is the part that Stanford will be working on in particular. A curated sample of probably 15 to 20 highlighted collections where we will go much more deeply into contextual documentation and the use of components of GitHub repos that may or may not be included in the way that the overall archive is ingested. So things like comments and requests, the bug reports, the stars, all of those sorts of things. How can we incorporate that into overall context? This will be the Stanford contribution, I think probably mostly in collaboration with Software Heritage among the partners there, because Software Heritage has already done some work like this. In particular around a couple of the projects that we've already identified from the Stanford side as being of interest. Just to give you a quick idea, here are some of the kinds of things we think will be in the sample, some of the examples of software that will be in there. The virtual Apollo 11 guidance computer, the AGC, that's a project that Software Heritage has already done some work on. The NARA digital preservation file format risk analysis kind of outreach. We wanted to have a project, at least one, that focused on the fact that GitHub is not just used for software anymore. It's also used for documentation and for distribution and archiving of documents. The virtual stethoscope project, Papers We Love. Why Papers We Love? Because it's the most popular project in GitHub, has been for a while. Freedoom, that's because Freedoom as a game, that's obviously an important community, but also because it ties back to the Preserving Virtual Worlds projects that I and Stanford also participated in earlier. Bitcoin Core, Droid, Minecraft community projects, ePad, the email archiving software that was developed at Stanford, things like that. So we want to have a sort of a diverse set of 15 or 20 deep dives into the GitHub world of software, in which we show the importance of supplementing the archive of the software with interpretation, context, metadata, all of those kinds of things that will be very important to future historians to have to make sense of these projects. And by the way, another thing I have to add there is that very often the most detailed information about a project that is available as a GitHub repository is not in GitHub. It's on a website or something external to GitHub. We will want to show how those things can be interconnected as part of this project. So that's what the GitHub Arctic Archive project is. There's a lot of talking left to be done among the partners in terms of what we're actually going to do. To give you an idea, I think Stanford first found out about interest in our being a participant. Let's see, we launched in November, maybe September. We first found out about this discussion. So we're at a very early stage with this, and certainly comments are welcome. I think I'll stop there because we're almost up to 9 o'clock.
Henry, wonderful. Thank you so much for giving us an update on both. Very exciting about the Silicon Valley Archives. And certainly, I think we would like to invite you back, all three of you back. Certainly, there's a lot of updates to see where each of these different things go. For Moraine, I'd be interested to see what kind of community feedback that you get between now and maybe the next community forum on the use of the acquisition process. Zach, I would be really curious to hear more, as I'm sure our attendees would, about how you can take what you've done with Dr. Cardoso's class and maybe think about that in other disciplinary contexts. So I know the architecture school has been like a willing participant in this experiment, and also there's a big interest generally in architectural files and how you are able to extract meaning from the data in these proprietary architectural project files. So definitely an update on that to see how you can kind of franchise or scale the pedagogical uses of emulation and legacy software. And then Henry, obviously there's a lot I'm sure there will be big updates about how both the GitHub Arctic Archive project progresses, but also how this attempt to take a different look at collection development when it comes to the Silicon Valley Archives, as far as voices that are currently underrepresented but have made like a huge and significant impact on the history of computing and software. So I think there's a lot of room for updates from all three of you. I was buying some time there to see if we have any questions from our attendees, but given that we're about a minute from the top of the hour, one thing I'll just say is thank you to each of you for taking the time to share the work that you've been doing. And I would encourage all of our attendees one more time to see if you can paste a question in there in the next few seconds or into the meeting notes document after we close the meeting, so that we can circle back with Moraine, with Zach, and with Henry. And thank you as always to our attendees. Without you, I mean, this is who it's for, but it's also why it's meaningful. So thank you all so much for joining us. And we're getting some thanks to our esteemed guests from our attendees. So yes, ditto. Thank you all so much for coming. And yeah, I hope you all have a wonderful quarter until we see you next
Thank you.
Thanks, Jessica. Bye.
time.
Thanks,
Thank
Jessica,
you.
for facilitating. Bye, everyone.
Bye, everyone.